Now we are going to do the expression. Please start. Start reading.
The acceleration produced in a body is directly proportional to the force acting on it and inversely proportional to the mass of the body.
Okay, just a moment. Now A is equal to F. You agree? You agree?
Yes, ma'am.
So it becomes directly proportional, right?
Yes.
Yes? Okay. Now the next one is A is equal to 1 upon M, right? Yes or
Yes.
no?
Yes, ma'am.
Okay. So it is inversely proportional to mass. Now you understand what is the meaning of directly proportional and what is the meaning of inversely proportional? If it is 1 upon something, it becomes inversely proportional. If it is direct, then it becomes directly proportional. Is it clear? I'm just trying to make things simpler for you. Why we call it is directly proportional and why we call it is inversely proportional, I tried to show it to you. Have you understood it nicely?
Yes.
Yes.
So what is the definition? Extraction is equal to force upon mass of the body, right? This is what you have to remember. Or otherwise you can even write F is equal to MA. Remember we know this formula. Do you remember now? So
Yes.
F is equal to M into A, right? This is what we know, isn't it, Beta? Okay? Fine. Now begin.
Force is a vector quantity. Force can cause acceleration or deceleration.
Deceleration. Yeah.
Deceleration.
Acceleration means, yeah. Acceleration means going forward. And where is deceleration? When you apply brake, the body goes back. Agree? When you
Yes.
apply brake, the body goes back. That is called as deceleration. The other word is retardation. What is the other word, Beta? Retardation.
Okay.
You got my point now? Okay? Fine.
Okay, ma'am.
Now,
Example. Acceleration of a car accelerates it and brakes decelerates it.
decelerate it. Okay. Now you understood?
Yes.
Okay.
SI unit of force is Newton.
Okay.
One
We know
Newton
that.
is 1 Newton is defined as that force which when acting on a body of mass 1 kg produces an acceleration of 1 meter
Per
second
second.
square
Now,
per
beta,
second
just read it properly. Yes. 1 meter per second square.
1 meter per second square in it.
Then,
Place an 100 gram on your outstretched palm. The
ah,
force you feel is nearly 1 Newton.
you understood now? Whatever you place, whatever mass you place on your palm, on your hand, anywhere, it is absolutely nearly 1 Newton of the force that is applied on your palm. You understood? You understand? This is the universal. Okay? So we know that force is a vector quantity. It can produce acceleration as well as deceleration. When you speed on the accelerator, your car moves with a high speed. And when you apply brake, the car goes back. That is deceleration. We know the unit of force is Newton. And what is 1 Newton? It is a force which is acting on a body which has got mass of 1 kg and it produced the acceleration of 1 meter per second square. Then and then we call that force is 1 Newton. You understand? So mass has to be 1 kg, acceleration has to be 1 meter per second square. Then and then the force will be 1 Newton. Now we will see the applications of Newton's second law of motion. Yes, please continue, beta. Now Abdul Qadir can take up the charge, beta.
Yes, ma'am.
Begin.
I
Okay,
was
fine.
reading.
Okay, you were reading. Okay, I'm sorry. Okay, continue better.
Application of Newton's second law of motion. First, a cricket player fielder moves his hand backward on catching a fast moving cricket ball.
You agree with it? You must have observed cricketers catching, or the fielders catching a ball. They take the hand back along with the ball. If they don't do it, then the ball bounces back from their hand and then miss the catch. Have you observed that?
Yes, ma'am.
So you can see over here, this is the
Yes,
ball.
ma'am.
Yeah, please read. Why they do so, we will read one by one.
A fast moving cricket ball has a large momentum.
What is
In stop
momentum? Mass into velocity. What is momentum, beta? MB,
mass into
mass into
velocity.
exactly. You know that, right? So when it is
Yes.
coming back, it is coming back with the gravity. Now the gravity is working on the ball, isn't it? So obviously velocity increases, don't you feel? And even it hits us badly because of that force. Okay. Then
In stopping the cricket ball, its momentum has to be reduced to zero.
agree?
When a player when a player moves his hand back, the time taken to stop the ball increase and hence the rate of change of momentum decrease.
That
For
means
ex- Therefore, the force exerted by the ball on the hand decreases, so the player do not get hurt.
so if you try to stop at once the momentum of the ball, you may get hurt. Do you follow me? But what you are doing now, you are trying to hold the ball, you're increasing the time to catch the ball. You understand? So, what am I doing? I am trying to decrease the speed or the momentum of the ball in my hand. Yes? So, I will not get hurt and I can even catch the ball. What do you say? Do you understand what I said just now?
Yes, ma'am.
Yes, ma'am.
All of you? So, I am giving it
Yes.
more time so that the speed of the ball decreases. And if I stop it at once, suddenly, I will get hurt or I may lose the catch also because the ball will bounce back because it's coming with a large momentum. So the ball will bounce back from a hand because I'm abruptly stopping the ball. But in the other case, when I'm putting my hand down, I'm giving it more time to reduce the speed, to reduce the acceleration, reduce the momentum. And there's a chance, there's a probability that I will catch the ball. Understood? And
Yes,
moreover, my hand will not be hurt, right? Because the speed, the momentum has decreased. You understand now, Vita?
yes,
All of you? This is the second law of motion. All of you understood, Vita?
Yes, ma'am.
Some more examples of second law of motion.
high jumping or long jumping athlete is provided at or either a cushion
Cushion.
or a heap of sand
Heap, heap.
on the
It is heap.
ground to fall
Please read
upon.
properly. Abdul,
Yes,
it is heap.
yes, ma'am.
Yeah, it is a heap of sand.
A heap of sand on the ground to fall upon. The cushion or sand help to increase the time in which the momentum comes to zero. This decreases the rate of change of momentum and hence the force, so the athlete does not get hurt.
Have you ever done this high jumping or long jumping, Vita?
Yes, ma'am.
Have you ever done high jumping or long jumping? Yes. So when you jump, you don't jump onto a ground, flat ground, or a concrete ground. Can you do that? Because if you fall on a concrete ground, you may break your bones, isn't it? So what has to be done? Because we are coming with a force, we are jumping with a force. So we may break our bones. So this thing should not happen. On the other side, what is been given? A heap of sand, or or it is given a cushion, so that when you fall, with the impact, the momentum, you are not hurt and you don't break bones. You understand? Hello?
Yes.
Understand? So the momentum comes to zero. When you hit the cushion, when you fall on the heap of sand, the momentum becomes zero and you don't get hurt. Do you understand? The speed becomes zero when you fall on the sand or on the cushion, isn't it? You're not moving, but you're not hurt, right? Okay,
Okay, ma'am.
let's see the third example. Please read.
Picking materials like thermocol, corrugated sheets, bubbled plastic
Bubble.
sheet,
You
bubbled
keep saying.
plastic sheet,
Thank you.
straw, papers, threads, etc. are used while picking glassware, chinaware,
China
electronic
ware.
device,
China ware.
chinaware, electronic device, etc. This
Have
material
you ever,
helps to
okay. Have you ever observed all these things?
yes.
Fine. Continue.
These materials helps to increase the time in which the momentum comes to zero when jolting on and jerking take place. This decreases the rate of change of momentum and has hence the force, so the articles do not get broken.
Fine. Now we are shifting from one place to other, right? Papa got posted, or for some or the other reason, we are shifting from one place. Okay. If you take steel wares, the steel or the iron materials, you don't have to pack so nicely. But if you talk about the glasswares, the delicate articles, we have to give the packing, isn't it? So that when it is moving from one place to other, due to jerking, the glasswares don't break. You understand now? Hello.
Yes, ma'am.
So what is happening now here? The momentum due to this packing comes to zero. When it is jolting, when it is moving, when it is shaking, when it is jerking, the glasswares don't break because the momentum will come to zero due to the packing material that has been used around it. You understood now? It is not allowing it to move. So the momentum is zero.
Yes, ma'am.
In spite of jerking, in spite of jolting, in the transport, this packing material is not allowing the glasswares to move. So momentum is zero and the glasswares are not broken. Hope you understood better.
Yes, ma'am.
All of you?
Yes.
Now, first, second law we have finished. Now we are going to work on Newton's third law of motion. Start better. Please begin. What happened?
Ma'am, Abdul Qadir has left.
Okay, so you take it up the charge better. Anyone can read. It's not. Maybe there's some internet problem at his place. Maybe that's why he may be removed automatically. So any of you can start the read. No problem. The class should go on better. Please start.
Newton's third law of motion. Newton's third law of motion states that to every action there is an equal and opposite reaction, and they act on two different bodies.
So what is that? Every action. Now, if you are shooting a rifle, for example, you're shooting with a rifle, the bullet goes ahead. See, this is the rifle, right? This is the rifle. The bullet goes ahead, but there is a jolt back. It hits your shoulder. Have you ever heard of this? That when you shoot, it recoils. The rifle hits you back when the bullet goes ahead. Yes? Have you ever come across this sort of incidents? Have you ever heard of that when the bullet is fired, the rifle recoils, the rifle hits you back on the shoulder. That is called as reaction. Action is firing the bullet. Reaction is the the backward portion of the rifle hits you on the shoulder. That is a reaction. So it's every action. Action was shooting the bullet going ahead. That was action. And what was the opposite reaction? The muzzle of the what do you call this? The rifle is hitting you back on the shoulder. That is a reaction, and it's acting on two different bodies. The bullet is hitting the wall, and the rifle is hitting your shoulder. So it is acting on two different bodies. Hope you have understood this in this example.
Yes, ma'am.
Okay. Now, how to prove that action reaction are equal and opposite? So one by one, line by line, we are going to explain. Please begin between.
To prove that action and reaction are equal and opposite, take two spring balance A and B, connect together. Fix the spring balance B and
Yeah.
rigid
Especially a rigid
support.
support. Yes.
When a force is applied by pulling the free free end of the spring balance A, both the spring balance shows the
Same.
same reading. This shows that the force extracted by the spring balance A on B is equal but opposite in direction to the force extracted by the spring balance B on A. No, the force extracted by the spring balance A on B is action, and the force extracted by the spring balance B on A is reaction.
Reaction. Good. Something you understood or not? This is the activity. What we had learnt that the spring balance are connected over here. Can you see this connection by the hook? So both A and B are connected with the hook. Yes? Hello?
Yes.
Yes, fine. Secondly, B is having a rigid support. Yes, it is tied to a wall. Agree?
Yes, ma'am.
Yes? Okay. A is free. We are holding it, so it is free. Yes? It could be you, it could be me, it could be anyone. So it is free end. Agree?
Yes.
Now what has to be done? We are applying a force. We are pulling it. What are we doing? We are pulling it. Yes or no? So
Yes.
when we pull it, we can see the markings on both the spring balance the same. You saw this? This much you understood or not?
Yes, ma'am. Understood.
So what are we doing? I am pulling this. So A is action. Agree? I am pulling A.
Yes.
A is action on B.
B.
You got it now? So this is
Yes.
action and this is reaction. Agree?
Yes.
So it is equal and opposite. What do you say?
equal but
Yes, it is
opposite.
equal but opposite. Okay, done now. Hope you have understood this. So A is action and B is reaction.
Reaction.
This much have you understood? And both are equal. Can you see this? 100 Newton. Both are equal, but opposite. Is it clear?
Yes, ma'am.
Because I am pulling this and this is fixed over here. So obviously the fixed will be pulled like this. What do you say? Because it is stuck to the wall. So it is pulling, the wall is pulling the spring balance towards itself, isn't it? Doesn't matter that we are pulling both the spring balance, but the wall is also pulling it. It's not letting it go. So the reaction is on the opposite direction. Again, we will explain the same thing with different activity. Please start.
Newton's third law of motion. To every action, there is an equal and opposite reaction. The statements mean that in every
Interaction.
interaction, there is a pair of force acting on the interacting object. The size of the force on the first object equal the size of the force on the second object. The direction of the force on the first object is opposite to the direction of the force on the second object. Force always come in pairs, equal and opposite. Action reaction. Force pair.
Now, first one, what we learned, equal. So forces are equal, agree?
Yes.
Then it is opposite, agree?
Yes.
Opposite to what? To the direction. You agree that?
Yes.
Yes? And it comes in pairs. That means action and reaction. Understood?
Yes.
This much you have understood? The same thing has been repeated in different way. The wordings are different. But if you have understood the first one, the earlier slide, then this is very easy. What do you say?
Yes.
Yes? Did you find any difficulty in understanding better?
No, ma'am, understood.
Start. Now, what are the tips that you have to learn? We do one
Action
by one.
and action and reaction are just
Forces.
forces. The force always occur in pair. Action and reaction do not act on the same body. Action and reaction act on different bodies, but
Simultaneously.
simultaneously.
Say it again. Simultaneously. Say with me better.
Simultaneously.
Very good, very good. See, you're doing very fine. Hmm? Okay.
Through
Next.
action, through action and reaction,
Do.
force
It's
are
do.
equal
Read it again.
forces.
Do.
So action and reaction forces are equal in magnitude, but they do not produce
Produce acceleration.
equal acceleration in the two bodies on which they act.
So you understood? Forces are equal. Action and reaction forces are equal. But the acceleration are not equal in those two bodies. Do you understand?
Yes, ma'am.
Okay, because see the spring balance which I was pulling will have more force as compared to the other spring balance which is attached to the wall. You agree? So the
Yes.
acceleration will be different. Acceleration will be different, but in magnitude those forces are equal. That's 100 Newton, 100 Newton is showing. But acceleration wise, the speed wise, the velocity wise, it will be different. You understood now? So the object which
Yes.
is near to me will have more velocity to the object which is reacting because it is away from my body. Hope you have understood.
Yes, ma'am.
Okay. Same thing. Newton's third law of motion. See, in a different manner it's been shown. So this is action. Why action? Because I'm pulling it. This is action. It is in the opposite direction. Can you see this? It is pulled over here. And the other one, it's me who is pulling here and it's you who is pulling there. Right? So
Yes.
action you can say and the reaction you can say is both 50 gram weight. Can you see this? Both are same. But now it's opposite, it's on the different objects, it's same, you understood? But the acceleration will be different. Hope you have understood.
Yes, ma'am.
Hope you have understood.
Yes.
Now you take a ball. What you do? You take a ball. And this is a wall. What is this? Wall. Right? You hit it on the wall. What happens? It comes back, it bounces back. Am I right?
Yes.
So hitting the ball onto the wall is action. Agree?
Yes.
The ball bouncing back to you is
Reaction.
reaction, which is in opposite direction. Understood better?
Yes.
Do you find it easy?
Yes.
If you understand, then it is very, very easy. Any problem, you can stop me.
Okay, ma'am.
Right? Okay. The same thing what just now I taught you when we started with the third law of motion. Again, we are going to do this is the same Newton's third law of motion. We are giving more and more examples so that things become very easy for you to understand. Examples of action reaction. Please start with a
Example of action and reaction. When a bullet is fired from a gun, it
just
extract.
understand just understand better what I taught you. Okay? Just understand. While reading, try to recollect what I taught you. Okay?
Okay. When a bullet is fired from a gun, it
Exerts. It exerts.
exerts forward force action on the bullet, and the bullet exerts an equal and opposite force on the gun reaction at the and the gun recoil.
Understood? So what is the action? The bullet going ahead. Agreed? Be
Yes.
fast better. And it is accelerating force. So it's going with a high velocity, right?
Yes.
And the gun is pushed back. That is reaction, which is called as recoil
Recoil.
force. Understood? Understood?
Yes. Yes.
Okay? So bullet is going ahead,
Ahead.
that is action, and the rifle is going back, it is hitting your shoulder, is the recoil force, which is reaction. Any problem?
No, ma'am.
Okay. Now the next. This we must have observed many times. Read.
When a sailor jumps out of the boat, he extracts a backward force of the boat action, and the boat extracts and
Exerts.
exerts
Please.
an equal
Exerts. Beta, it is exerts. Split it.
ex
Say exerts.
ex exerts
Exerts. Got it now?
exerts.
Very good.
Yes, ma'am. Exerts an equal and opposite force on the sailor reaction. and the sailor jumped forward.
Understood now? It may be you. For example, we are on the boat. As soon as we go ahead, what happens? The boat moves back. So, what is happening? When this man, the sailor, he is giving a backward force, that is action, then and then he can move forward. You understand? He cannot move forward without pushing the boat backward. You understand or not? He cannot jump straight away. He has to apply force. When he's applying force, the boat moves backward, which gives him the force to jump onto the bank or onto the land. You understand? And that jumping becomes the reaction. Now, these two are equal. Action is equal to reaction, but they are opposite in direction. And the boat and the land, they are two different objects. Any problem? Any problem? So the
No,
backward
ma'am.
force, so the backward force is
No.
action, and the sailor moving ahead is the reaction. Because until unless he does the action, he cannot react. He cannot move. He cannot move the or he cannot move out of the boat. Till the boat goes backward, he cannot jump onto the land. Do you understand?
Yes, ma'am.
So that moving of the boat is giving him the momentum to jump. Remember that. Got it?
Yes, ma'am.
Some more. You will understand very nicely now. I've taken many examples. Yes, better start.
When an air-filled balloon is released,
Released.
the force of the air coming out of the balloon action extract
Exerts,
exerts
yeah? Thank you.
ex, exerts an
Exerts.
equal and opposite force on the balloon reaction, and it moving upward.
It moves upward, right? So
Yes,
this is
ma'am.
a air-filled balloon. This is a air-filled balloon, right?
Yes.
So what is happening? What is happening? I am taking out the air out of it. I am taking the air out of it. I've opened the mouth. What happens? The force is coming out of the balloon. That becomes action. So this is action. The force with the air is coming out of the mouth of the balloon, right? It is action. And what is the reaction? It moves upward because it becomes light. Either it goes backward or it moves upward. Understood? You
Yes,
try it
ma'am.
with the balloon. Why don't you try it with the balloon at home? You fill the balloon, hold the mouth of the balloon, and allow the air to pass through. You open the mouth of the balloon and see what happens and leave it. Either it goes backward or either it goes upward. Try it and let me know. So, what you are doing? You are allowing the air to pass out, that is action. And what is the reaction? The balloon going backward or upward because it has become light, isn't it? Hello?
Yes, ma'am.
You understand? So, do this
Yes,
activity and
ma'am.
let me know.
Oh,
All of you understood this one?
yes.
The same thing applies for rocket launching. Start.
When a rocket is
Fired,
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 force of the burning gases ex- ex-
exerts.
equal and exerts and equal and opposite force on the rocket reaction, and yeah, and it move upward.
Fine. Similarly, we can see in rocket, when we are firing a rocket, what happens? The gases are burnt. Can you see this? The gases are burnt
Yeah.
and it comes out. So this becomes action because until and unless gases burn, the rocket will not move. You agree with me?
Yes, ma'am.
Gases have to be burned. No, that is fuel. If it does not
Yes.
burn, do you think it will get the energy to go forward? No, isn't it? So what is action, beta? Burning of the gas, burning of the fuel, that is action. So action is burning of the fuel, right? What is the reaction?
Yes.
It goes up, it goes up. So it gets the force by which the rocket moves upward. Obviously, it is moving upward on the opposite direction, that is reaction, and it starts moving upward in the space. Any problem?
No, ma'am.
So action is burning of the fuel, reaction is rocket with a force going into the space. Okay?
Yes.
See this one again? Same. Third law of motion. This is a pistol. What is this? Revolver. Okay? Force on bullet, that is action. So bullet is coming out. This is action. So what is reaction? The force which is applied by the bullet onto the gun, it goes onto the backward direction and your hand is pulled back. That is reaction. What we learned, recoil, isn't it? Recoil force. As we saw in rifle, this is pistol. Same thing applies over here. This one. Someone's mic is on, better. This is the rocket or the space shuttle, whatever you say. This is how it moves upward. Can you see this?
Yes.
What is action? What is action? Burning of gas, right?
Yes.
This is action. What is reaction? The shuttle going up, or the rocket going up, or the missile going up, right?
Yes, ma'am.
Okay. How do we walk? I'll just explain to you.
Yes.
This is forward motion. Your foot is moving in the forward direction, right? You are applying a force on your
Yes.
heel. You are applying a force on your heel. Then and then only your foot will go ahead. Yes or no?
Yes.
Yes? So your toes and the complete feet along with the heel is in motion. So the forward motion is what? Tell me what? If this is pressing, for example, this is action, then the heel becomes reaction. And if heel becomes action, then the toe becomes reaction. You understood now? Because
Yes.
it is moving in tandem, it is moving simultaneously. Only toe is working, you cannot work. Only heel is working, you cannot walk, right? So both have to be simultaneous. So when you apply a force on the toe, later you get a reaction on the heel and you walk. When you put action on the heel, the toe comes as a work of reaction. And that's how we walk with both the feet. You understand better?
Yes, ma'am.
The same thing. The sailor thing that I showed you. Action is the boat is being pushed backward. And reaction is you jumping from here to here. Right? Action is
Yes.
pushing the boat backward, and reaction is you jumping from the boat to the land. Yes. Let's start. Horse and cart problem. Please start. Yes, better.
Horse. Art. A horse is or a
Urged. I cannot hear you properly.
a
Hello.
horse is hello.
Yes.
Now my voice is coming, ma'am.
Yeah, now clears. Continue.
A horse is urged to pulling a cart.
The pull,
The
beta.
horse
It is not pulling. It's pull.
pull a cart.
Hmm.
The horse
Refuses.
refuses to try.
Hmm. Citing,
Sitting
citing,
Newton
citing.
citings Newton's third law as his difference.
Defense,
The
defense,
pull
defense.
difference. The pull of me on the cart is equal but pull opposite to the pull of the cart.
On
If
me.
I can on me, if I can never exert a greater force, action and reaction are always equal. On the cart, then it
Then
exerts on me. How can I ever
set
set
the
the
cart.
cart moving?
Ask the.
Ask the horse. How
Can you think of
would
this? Okay. How would you reply? How would you reply? Now, this is the problem of the horse. Horse is telling the person who is driving the cart that according to Newton's third law of motion, action has got reaction. So the cart should not move. Car should not move. No, according to third law of motion, the car should not move because action and reaction are equal. What do you say? But the rider wants the cart driver wants the car to move. What he will do, please think and we will talk about it tomorrow. Yes,
okay, ma'am.
boys? So you think it over and let me know how the cart driver will make the cart move. Because the horse says the cart should not move according to the Newton's third law of motion. But still the car driver wants the car to move. How he will do it? Think it over and we will discuss it tomorrow. Okay, beta?
Okay.
Okay? Till then, have a good day. Bye.